Hey everybody, welcome back to the Unreal Engine training stream. I'm your host Alexander Pascal, and joining me today is Amanda Bott, Lauren Ridge, and Richard Hinckley. We have a full house here today. This is actually about as full as it can get.
I was about to say, I think this is the most people we've had on the training stream before.
Yeah, I think this is kind of the cap. We've
had
had,
people like sitting
we've
here.
had
Come
hot
on.
swaps, but we've never had anyone like, yeah, just come and chill out on the floor or something, which would be kind of fun. But today's topic is C++ Q&A. A ton of people have just asked us questions over time about, like we did this getting started in C++. We did the Tank C++ live streams as well. But accumulating all these questions means that we should probably answer them. So you guys have a little bit put together. We have Q&A towards the end as well. So if you're watching us live, feel free to just throw it into chat, and we'll hopefully be able to answer all of your questions. If we can't, go to forums.unrealengine.com and throw your questions in there as well. So I'm going to let y'all just kind of take it away, and we can throw it up on the main screen unless y'all want to say anything first.
No, I think we're ready to go.
No,
We're
okay,
pretty much
cool.
ready to go. So we did one of these before, and we had a bunch of questions on the forum, and we're going to kind of head into two of the main areas that we had questions about, which were data storage and casting. Those are the two areas where we just seem to get a lot of questions.
Yeah, for sure.
All right, so the first thing to say about data storage is that the format in which you store your data needs to be based on what you want to do with that data. So if you need to know every enemy in the game that's currently alive for whatever reason, an array would probably be fine, because you could just have an unordered list of all of them, and that's okay. If, on the other hand, I want to know all the players that are currently in the game, and I'm going to frequently ask for a specific player by name, then I might want a set, because I can only have one player with a given name, and I want to be able to find that quickly. I don't want to have to look through every single entry in the array.
Is this Alex's character? No. Is Amanda's character? No. You just want to be able to find the Richard character.
I said set. I meant to say map.
Yes, map has got the key. So
Right.
you would say we had an array of, or a map of the four of us. It would be, the keys would be Alex, Amanda, Lauren, and Richard, and then you'd be able to instantly go look up by the key and then get,
And then get
color of plaid they are wearing or not wearing.
So
It's a series of nulls.
the plaid and then null.
One red
Yes.
plaid, red and black plaid. All right, cool.
Yeah. So the difference between a set and a key would be if I just needed the names of everyone in attendance, and we assume that no two people have the same name. Maybe it's your full name, maybe it's your social security number, whatever it is.
Stop trying to get our social security number.
Look,
We're not going to give them to you for the stream. I know you've tried. Yeah.
eventually it's gonna happen.
We'll just totally slip up. Here you go.
So since those are unique and we only need that piece of data, we don't need another associated piece of data, that's where we'd use a set. We'd use a map if we want to take that number and then also know what their home address or credit card number or mother's maiden name was. If you
First pet, the name of your first pet,
yeah,
your uncle's
name of your
name.
first pet, right?
Yeah.
All that kind of thing.
When they're taking their next vacation.
Is that one of them now? I haven't answered enough security questions lately. I should really sharpen my game. All right, so the three things that we're really going to talk about there are going to be arrays, sets, and maps, and that's kind of the three usage. So there are advantages and disadvantages to each. When we talked about how memory is laid out before, we talked about how memory is essentially just a long one-dimensional buffer, and so an array is just a block of that. So if you have some sort of piece of data that's 4 bytes in size, like an int32, and you have an array of 10 of these, that's going to be a 40-block byte of memory. It's really compact because you don't need anything other than just the 10 pieces of data stuffed back to back, and that's it. So if you don't care about the order or about searching them or sorting them, array is perfect. Minimum size, really fast to add things to the end of it, reasonably fast to remove things from it. It's all great. As soon as you start wanting to look things up or make sure that things are unique, an array starts being not as good. So we're going to look at that right here, actually. So I've written a little piece of code. It's just a little dummy actor that when you put it in the world, it does just some operations with memory, and then print some stuff out. Oh, it's not even really math. It's just adding one by one to an array, a set, and a map. Now the map has a little bit of a disadvantage because with the map, it's a map of ints to floats, both of which are 4 bytes. So you're going to have, so here we're going to add the numbers from 0 to 22 into the array. And that's fine, that'll all work fine. Here we're going to do the same thing for a set, and critically, I is going to be a different value every time, because otherwise the set would reject duplicate entries.
Right.
That, by the way, is why the set takes longer to add to, because instead of just sticking it on the end, it actually has to check to see if this is already there, then it can stick it on the end. And the float has,
map, yeah.
has a bit of a disadvantage. Yeah, the map of the insta floats has a disadvantage because it has the int for the key, and I had to make up a value for the float, so I just took the value of the int and made it a float, whatever. But the point is that it has 2 pieces of data per entry. This would be less of a disadvantage if we weren't using such a small entry. Like if we had a big piece of data and a little key, that wouldn't be such a big deal. But when the key is the same size as the data, the map is going to look disproportionately expensive. So
Right.
just bear that in mind. It's not an entirely fair test. But yeah, let's do that. We're going to run that right away.
Let me know
And
if you guys need me to get the picture
Okay.
out of the way.
oh no, it's okay. We're really only looking at the output log. So we're going to play and end. And as you can see, when we start playing, whoops, let's go to our log. I love using warning on this, by the way. We'll talk about debug outputs in this engine in a minute because you need them. But all right, so when we start out, everything's not really taking up any space. I mean, there's going to be a little bit of overhead, but there's pretty much no space allocated for the data.
Right.
As soon as we add to the array, and the array has a special column on the end here, this 4, the array actually will, when you exceed its size, it will oversize itself automatically because it doesn't have any idea how much stuff you want to put in there unless you tell it ahead of time. So it will expand, and it'll expand in bigger and bigger increments as you continue to break its size limit.
Kind of pre-allocating some size in case, like, I don't know if you're going to add 3 more things or 10 more things.
Yeah. I mean, like if I just asked you to hold something for me and you were very compliant, you would say yeah, and you just put it on your desk probably. Once I get up to about 5 or 6 things, you're gonna be like, okay, I'm gonna need a box to sit next to my desk for this. Okay, I'm gonna need a storage locker
Right.
for this. Right? It just sort of grows in leaps and bounds, and so that's how the array works. So the array, you'll notice, starts at 0 using no memory, whatever. That's expected. As soon as you add your first thing, it jumps up to 16 bytes because it gives you enough space for 4 things.
Okay.
So it's a 4-byte int. It gives you enough space for 4 of them. And you'll notice even when we go up to 4 of them, the array is still at 16.
Because you haven't exceeded the size again.
Right. We go up to 5, and the array immediately jumps up to 22. So now it's taking 88 bytes. But this is still pretty small. If you look at everything else,
Yeah, it's still smaller than the set.
the set is 68 bytes for one thing. The float, bear in mind that the thing is double size because it's an int and a float, is 84. And as you get up here, you'll see the set and the map stay the same size for a while too, and then they also jump up to 128 and 144, and 344 and 432, and then they stay there for a little while. And then eventually they jump up again. Yep, right down here.
Meanwhile,
So-
the array has jumped some, but not nearly as much.
Yeah, I mean, yeah, this jumps to 408 and 496 while the array is still at 88 bytes. So the array is clearly the smallest because it's just a block of memory. It's the absolute minimum size you need. It's the simplest possible storage mechanism. But yeah, there we go. And at the end there, you see, I stopped it at 23 because that's the point where it jumps again up to 47. But it's pretty minimal size. These other ones, you'll notice, will maintain their size for a while, and then they will also jump up drastically. So, so that's the advantage of an array. Now let's see, where are we here?
The nice thing is, too, that all of these are now things you can expose to blueprints. So if you're a programmer who wants to expose some variables to
Okay.
the designer they're working with, you can actually create, you can see them as blueprint types also.
Yes, in fact, they're right here. Here's my array, here's my set, here's my map. Just right there. We could add stuff to them right there. Of course, it's done dynamically in the program, so we don't need to do it here. But, oh yeah, and I did that. So let's make this a slightly better testing tool, and we'll use this to do it.
Okay.
So right now I have hard-coded the number 23. This is just debug code, so it's not the absolute worst thing in the world to do, but in general, don't do this. This should be something like...
Oh, you mean no hard coding magic numbers like 23? Yes.
Yeah, try not to do that. I hard-coded it because I happen to know that number. Array size debug test, I believe is what I called this. Whoops. We do not have vax. Okay. Okay. I forgot to check that beforehand, but it's really okay this time. All right. So I made a variable for this. And I just want to show this cool little meta thing here. This little meta tag, edit condition, B debug mode is true implicitly. So that condition is kind of neat because if I turn debug mode off, this becomes not editable anymore. I just like that.
It's really nice. It's like if you need some variable to rely on some other variable and it wouldn't make sense to set it by itself, then you can actually make that dependence something that will show up in the details panel for, say, somebody else working with you on the project who doesn't know that that debug test only gets used when you're in debug mode.
Yeah, yeah. And you can also use it for things like maybe you have something that you'll have a region in the game where when the character walks into this zone, something happens, but maybe you want it to happen repeatedly as long as the character stays in the zone. Well, maybe whether it happens when the character enters the zone shouldn't be an option if staying in the zone does it, because those are kind of redundant with each other. So in that case, you could turn off the enters, trigger on enter could be turned off if trigger on stay inside is turned on.
Right.
So something like that, just little convenience features. Oh, this is a neat thing too. If I can have, I've made this a uint 8, I can have up to 8 of these next to each other and they'll stack in the same byte. Instead of if I use bools, those are 32-byte bools, or 32-bit bools,
Right.
which is 4 bytes each. So 8 of those would take 32 bytes.
Yeah, if you have a lot of booleans in your header, it's best to put them next to each other if they're all like public or private or all the same visibility, and then also make them marked up like this so they'll all pack together.
Yep, this :1 is not a default value, by the way. It's just saying one bit.
Right.
And I can do this with a uint 16 or a uint 32 if I have more than 8 of them in here. But that's just something I don't know, I really like to do because it just feels bad to spend 4 bytes on a yes or no when you may have a lot of these objects in
If
the
you
world.
look at like the actor header, there's a lot of that in there, just like lots of uint 32s stacked together so that all this data about an actor can be packed really efficiently because you're going to have a lot of actors in your project.
Yeah, great for networking stuff too.
Yeah.
Okay, so
Yeah, I do have a
where
quick
were
question
we?
from chat about arrays, as long as we're
Yeah.
Sure,
showing this.
we're on arrays.
So Abatron was asking, will you be able to get from an array in Blueprints by reference? Currently, only get by a copy works. If you try to convert to reference, it doesn't work.
We'll be able to get an array by reference. You can't. Do you mean pass an array like as an
I would
argument?
assume it's like one that you've just created. You should be able to get a reference to it in Blueprint, though.
Yeah, I would think so. You should not have to copy that.
Yeah, that's actually probably something that we could put on the forums and have the gameplay scripting team chime in on, because
Okay.
as far as like,
I mean, I think you can, but yeah, they would be
Yeah.
the people who would definitively know the answer. I think you can do that, though. I don't see why you shouldn't be able to. Okay, so
cool.
we're going to use that value from the variable right there. And theoretically, of course, we should do none of this if we're not in debug mode.
right.
Oh, autocomplete. Actually, even this down here is debug mode. There we go. I do like that auto tab, though. For some reason, at home, I have that turned off, and I don't know where it is in the options.
I know some people do turn it off though for like where you have the U property markup and then you hit enter and then it
Oh.
indents underneath. So
I don't
kind of-
like that one.
I think some people will. I saw somebody on the Answer Hub was actually, or somebody linked that in our thread about here. If you want to not have it auto indent, like your variable or your function name underneath U function or U property, you can turn off that auto tabbing in the Visual Studio preferences.
So now, we're just going to clear the log. So now we should... oh, did I drop that? I think I made that logic wrong. Yep, that's wrong. Only if we are in debug mode do we do that. Well, we know it compiled.
Yes.
By the way, rapid iteration on code is a good idea, in case you do something like that. It's pretty good to find that out 30 seconds after you do it. It's pretty not good to find it out like 3 days later because you didn't run your code for 3 days. And then mysteriously something that you did in the last 3 days was wrong.
Yeah, that's a lot of stuff to dig through usually.
Yeah, it was a single character somewhere in something I did 2.5 days ago. All right, there we go. So now, as you can see, now it only goes to 10. And I think we proved that when we turn it off, it doesn't run at all. So there you go. So same thing. You can run little tests like this. It's almost like a unit test.
Right.
Little tests like this can be good to run just to just to make sure that you know what's inside of your structs and inside of your data structures and your storage. So I think that covers most of the basics of why you would use one of those three.
Actually, that just reminded me. So you could have a map that has one piece of data associated with, like the key associated with the value. You could also have a struct that has like just two pieces of information in it. What would be the benefits to using a two-member struct versus a set?
A two-member?
Or sorry, versus a map.
A two-member struct? You mean that where one of the members of the struct is the key?
Yeah.
I kind of like doing that. The reason I would do that sometimes, I didn't know I was on a test, but get a pop quiz. But okay, the reason that I would usually do that would be I need these two pieces of information anyway, and I might have another use for them. So when I recover this record from the map, I obviously know the key value because I had to ask for the thing by key value in the first place.
Right.
But then later on, if I want to use that key value, I might pass it to another piece of program code that doesn't happen to know the key value right now. But if it's in the struct, it definitely does know what that key value is, so I don't lose the
Pass
data.
the whole unit around.
Yeah.
The other thing I like is that you can name your variables inside a struct. So rather than key value, you could be like name address.
Yeah.
And so that
Or like
gives,
social security number.
so that gives a little bit of meaning to your data. The downside is then it's
It's going to duplicate it.
you could have duplicates.
Because the map, but also the map is going to hold on to the key as a separate copy of the key from the struct. So the struct has the key in it, and also, because it's just one of the struct's variables, but then the map also has a copy of the key separate, and the struct with its own copy of the key. So you do have an extra copy there.
Right. But like being able to name your subvariables, people.name, and rather than just people.key, where you're like, how did I key this map again?
Yeah. Yeah. So that would be a possible use for that. Yeah, it just kind of depends on what you need for your data, and doing little things like this can kind of help you out. I like using this a lot, actually, just making a dummy actor class, dropping it into a map, and having it output some debug stuff. Actually, let's just talk about debug stuff for a minute before we go into this. Okay, so I've used UE log. I really like UE log, and I like the fact that I can turn things up to warning level, and they show up as gold text like this, so I can easily see this stuff that I output,
Right.
and this stuff over here that I didn't output visually stands out. So I think I can even,
Yes.
yeah, I can even turn it so that like I just see warnings. So I just, like, this is just the stuff that I put in there. And then I go back and I remove all my warning logs that I'm not using anymore. Or you could just turn them down to just regular messages. They don't have to be warnings.
Yeah.
I think errors will actually break your program. I think I'm not sure.
I do know
Maybe it might only be fatal errors. Fatal errors, I think, might break your program. Yeah, regular errors are just red. So anyway, the point is that you can do that, and they're in here.
And also being able to sort by category is nice. Say you do have some that are warnings and some that are no.
I'm sorry. I just took the rug right out from under your feet there for no reason. Sorry about that.
So if you go to your categories,
Sorry, yes.
you can find like show all and then only show log temp. So like
Yep, log temp is right down here. So those are my messages. All happen to be log temp.
right.
You
so
just
you
turn
can
everything else
toggle
off.
them. So you can kind of see. Okay, I'm trying to figure out why. My lighting isn't quite doing what I want. You can toggle that on independently from other warnings.
Yeah, so that's another nice thing you can do here. And you can use any of these categories. I think I made my own once. I can't remember if you have to go into the engine and do that, or if you can do it at the project level. You might need to go into the engine and do that. In any case, there's so many of them, and log temp, I think, is not used for anything in the actual engine.
No, it's good for things like I'll just want to
So-
kind of leave a note to myself for debugging purposes. So.
Yeah, I almost always just use log temp warning, and that's enough for me. But there are many more options, and all the filters and categories too. So there's that, and then there's one other that's pretty useful. So that spits things to the log. You can also take the G engine, the global engine. There we go, engine object, and add. Oh boy, I wish I had backs. Debug message to screen. How good is my memory? My memory is terrible, but and I can't even hit Alt G to see if that's right. Oh man, I have to remember the parameters too. All right, so there's like a key. Oh man, Hold on. You know what? I actually.
Are you gonna
I actually
do
probably could
what I do
this.
for everything? Just
Yeah,
straight
you
to
just
Google.
type it into Google. That's how you program.
This is what we were talking about
It's the
before the
docs.
stream. Is like the most powerful
Yeah, it's the
programming knowledge
docs.
database. It's just Google.
And drag just that tab over. There you go.
This is
it.
me using like any function running anything I haven't done in a long time. It's like, you know what?
Yeah, I pretty
Just
much.
gonna Google it
I just did this.
just for safety.
I usually would have put UE4 or UE4
Yeah.
API or something, but today I was feeling.
You feeling confident that was like a very
Feeling lucky?
specific.
I was gonna say either saucy or sassy, but
there's
you
a
guys have
sample
thrown
code
in
in
lucky
here.
and confident, which are both good also.
Look at that example code.
Look at that example code. That looks like it was written by programming professionals of some variety. All right, so yeah, so here we go. We have the key, the duration that it'll stay on screen, the color, and then just an F string representing the text. Now the beauty of the key is that if I call this function again with the same key, it will just update that string in the middle of my screen. And let's actually write one of these. Again, programming is copying things from the internet and then just sort of pasting them into Visual Studio. And now we're programmers. All right, so if you add a key that's of negative value, or at least -1, that is just a message. It'll go up there. It'll never be overwritten. It'll just wait until it expires. But if I give it a real number, yeah, it's going to be yellow.
And I
And,
think if you just give it I there, you should be able to.
well, I's out of scope, but I can give it
Oh, array events num. There you
one
go.
of these. There we go. That'll work.
And this is actually, if you've used the print string node before, it's the same type of functionality. So
Oh, yes.
if you're coming from blueprints and you're like, how do I do the same thing? That's how you do it.
It's pretty much that. All right, do that, and then when we play, oops, did I do that right? Oh, well, okay. Let's make it more than half a second, for one,
There we go.
and let me just make sure I did all that right. Actually, you know what, I'm going to put it in here.
So it happens a lot.
Yeah, so I can
There
just
you
use I. That looks right. There we go, and now it all fits on a screen too. Okay. I don't know if our viewport if it's going to show up because of the way that our viewport is written, but it should be fine. Why is this not able
Oh,
to sequence?
let's see. If you want to click here on the drop down, oops, and turn off cinematic preview. Oh, that should do that. And then play.
Yeah, let's hope it shows up. It didn't show up. I'm disappointed that it didn't show up.
And it would be in the log, right? Even if it didn't show up on the screen, it should still be in the log.
Does it show up in log? I don't think it
This
does.
guy.
I know you can sort of toggle that as a.
Well, that's what I get for doing one thing on the stream that I didn't test before.
Let's see here. Chat says
Yeah?
rename the function. It's add on-screen debug message.
How is this? Oh, did it not compile and I didn't even
Add
see it?
on-screen debug message, not add debug message to screen.
Right, but that should have like not even compiled then.
Oh
which means that I
yeah, it
must
should have been
missed
like,
it telling
what?
me.
That's totally not accurate and
Yeah.
deprecated.
Okay, so remember when you're copying and pasting things off the internet?
to
to
copy
get the
them.
function name too.
Yeah, to copy and paste everything. Don't attempt to do anything on your own.
Oh.
Just assume nothing.
That's not how we program.
P.S. Do not take Richard's advice if you're working on your programming homework.
There you go.
Sorry, that
Okay.
was that was my
Compiler
former
failed.
TA in me coming out.
There
Alright.
we go.
Oh,
Compile.
wait, did I get it? Oh, I think hold on, I pressed that button a little early. Okay, that looks like it's done hot reloading.
Okay.
Now let's try it. There we go. And as you can see, it sort of, it got 10 lines, and then it, it's only going to output so many things on the screen at once. So if we give this a key value, anything like, I don't know if 0 works, but just take anything above 0. Probably 0 works. Negative numbers are definitely not. But take any number that's above 0. So we'll take 1. And then we'll come back in here,
File.
compile it. There we go, compile complete. We're going to actually see that this time. And I don't trust that.
Is your code behaving suspiciously?
It is. I just want to make sure. Yeah, on 1. Okay.
Yep.
Well, I honestly don't know what to say there. Add on-screen debug message. Let's go back to that check. I actually don't usually use this, but yeah. B new on top only works with index none, which is -1.
Yeah, and 0 looks like it should work there.
Yep.
The one thing you might want to do is just because, in case you were in Pi while you were hot reloading.
Oh yeah. All right. Let's just do that.
All else fails, save and just restart everything.
Yeah, I mean, you shouldn't have to. You rarely do have to, but every once in a while.
All the
know.
chat's like, you forgot to save the file.
It's okay if you don't save the file because running the compile process will automatically save it for you.
Right. And we don't
Yeah.
have anything, these are not under source control, so it's not going to be like, oh, you need to go check out the code or whatever.
Yeah. Now let's find our. Oops. That's not the project I was writing.
There was a project, it was CPP Proj.
Oh wow! I added all this code to Alex's project when I went to import
You're welcome.
my own project.
Oh!
That's why that's acting a little bit weird.
So that's a thing. It's like, what are you talking about? It's all fine.
Yeah.
That
So you
makes
just need to add
sense.
the actor there.
All right. So let's see. Yeah, I'm in completely the wrong project now.
Oh, this explains everything.
It does explain some things. Let me get up my Explorer window over here. I don't know how I did that.
Very carefully.
Well, not very carefully, arguably.
Programmer magic. I don't pretend to understand how any of this works. Well, no,
Okay.
wait, I do. That's
This
all I
is
do
the
is
one.
pretend I understand how any of it works.
There we go.
And it actually has code. And it was actually modified at 2:30 p.m., so good. That's the one we've been working on. Yeah, there we go. Okay.
Always blame Alex. Oh, thanks, chat. Yeah, this is so my fault. It was me. I did all of this.
Thank you for the tip, chat. I will blame Alex better next time. Even easier.
Especially since you'll be gone.
Yeah, so you
Yeah.
don't have to do it to my face.
There will be no
It's so
defense.
easy to do it behind my
He'll
back.
be hacking from Spain.
Yes.
Oh, it helps if you put the thing in the map, though. Boop. There we go. There we go. And now it's just one line of debug output, as you can see. Ta-da, everything works. Okay. Look, don't do anything live either. I mean, it's just only Bill O'Reilly is allowed to do that.
Yeah, so this is actually probably the most accurate depiction of game development live too. It's just like, oh gosh, why would anything compile it? I'm not even in the right project. Where's my coffee? I don't even know what's happening.
Alex!
Somehow
Just hear
Alex's
shouts
fault
from down the
anyway.
hallway. Yeah.
All right. So that all works now. You've seen that outputs the same line. That's kind of useful if you have something like a moving object and you want to keep logging its position or
Without
something
this
like that.
gigantic wall of spam that keeps reprinting, yeah.
Yeah. Just something you need to see updated every frame. Okay, so that all works as expected eventually.
And then file, open Visual Studio project.
And, oh, yeah, that's right. We closed that over there, didn't we? Thank you, Lauren.
Hmm. I just like that that's a button that's just right there at the editor. In case you,
I do too.
Yeah.
That's actually a pretty nice, helpful feature. I like that integration. Certainly better than when we had to close and reopen the whole thing every time, as opposed to just when I get confused. Okay, so let's see. We were in
Your My Actor class.
here in the actor class, and I think, oh yeah, we're going to talk about a couple things and then move on to casting. So we're making pretty good time here. All right, so we could talk about the array. So maps. I actually don't know how maps store keys in this engine. I could look it up, but I just haven't. Although it's clearly the same way as sets because the growth parallels sets pretty cleanly as we just saw. But there are basically two main ways that I've seen it done. Way number one is there's an array, and whenever you put in a key, it'll take that slot in the array, and there's your entry right there. The thing is, if my key is something large, like, I don't know, like a 9-digit number or something with 2 hyphens in it, that could be like, I don't just want to make an array that's that big, because that's gigantic.
Right.
Instead, I would want to have maybe something like a binary tree, which is a data structure where we start at the P brush, which is so a binary tree is a piece of data where we get our first piece of data right here, and that can have some number in it. This is beautiful. That could have some number in it. And then if I add another number to it that's greater, it'll go over here. Ah, that's a circle. And then if I add another number to it that's smaller, it'll go over
This is like
here.
the misshapen Apple connectors.
These are like, I grew up sort of near a power plant.
Oh, I
and these are
gotcha.
like the cherries off the cherry tree.
Yeah.
Right in the shadow of the
course.
power plant. So
Explains a lot.
thank you, it does. So what's really neat about this particular cherry tree is that as I start getting more and more entries into it, and these nodes would be shuffled around as you add them. So adding will take a little bit of time, more than popping something onto the end of an array would. But I just drew that 8 like a pro. All right.
Pretty good.
Yeah, I mean, one stroke there, by the way, everybody. That was one solid move. So the cool thing about this is that I can search this. This has 7 things in it. We don't have a 2 for whatever reason. I can search this in what's called n log n time. Yeah, in case you want to know what n log n would look like if it were written by a 4-year-old, that is what it would look like. So, so basically, well, not n log n, big O log n. All right, there we go.
You just erase
Yeah,
it.
production values going through the roof.
There's
on
a
this one.
text box.
I know there is, and I've known that the whole time, but I've deliberately just not used it.
I'll bring a
because-
tablet next time.
Because this is the aesthetic that we're going for. Oh, because it's going to look so much better if I hand draw things.
Oh, okay. I'll get you a Wacom. Yeah, that'd be great. Yeah, this
So-
is UE5. This will actually make game for you, Clint. When we're done, he's gonna hit a button, and this becomes
So
like an
basically,
RPG.
as you add more things,
Yeah, so if I had an array, you know, the fact that I can't see my mouse cursor makes this just more natural and authentic. All right, so if I had an array of however many this is, I'm not even counting. So if I had an array of this many entries, right?
No, it just has
and-
weird teeth.
Yeah, I just, so if I had an array and let's say 6 was in there somewhere, you would have to go through one spot after another. So that would be what we call an order of magnitude, a big O, worst case of n. So there are 7 pieces of data. Oh, I drew 8. I actually had it if I hadn't drawn that last tooth. There
but
we go.
say like the worst case being that
Right.
6 is stored at the end, and so you don't find it until you get to the very last.
Yeah, the worst case is going to be I look through all n entries before I find it. And more importantly, it's not that that's the worst case, it's that it scales like that. So if I have 10 things, worst case is 10. If I have 1,000 things, worst case is 1,000. It's that it scales linearly. That's what n is. Log n is saying 2 to some power equals n, and log is that power. So in this case, we have almost 8 things, right? We have 7 things. We have just under 8. So it increases like that. So this is 3, right? If I search for 6, I'm going to go start here, 5. Okay, is it greater than or less than 5? It's greater. Okay, spot number 2 is 7. Is it greater than or less than 7? It's less than. Third thing, I hit it. I hit 6.
Right.
Nothing here will take me more than 3 checks to find. And if I added another 8,
I contest you can't find it too.
except that one. So if I added a 2, well, actually, it will take me 3 checks to find out that 2 is not in the list.
Ah.
There you
So
go.
that is also our worst case. And again, down at the bottom, it would take me 7 checks. I'd have to go through the entire list and then go, I didn't find it.
Oh, okay. Okay.
So if I added a 4th row to this, just imagine 2 of those beautiful radiation cherries coming off of each of the bottom of those. I could add a 4th row with 8 things in it, which would bring my total things up to 15, and it would be 4 searches, right? I just over doubled my data size, and it's one more check to find any piece of data. I could put another 16 on the bottom of that, and now it's 5.
Right,
So
but if
you
you
can
did that with an
see-
array, you'd have to search, what,
Yeah.
15 or 30 something?
Or
yeah.
31, yeah. I mean, it would double, like my search time would double as my data size doubles. With this structure, my data size only goes up by 1 every time you double the amount of data in there. So you can see why if I'm searching a large database, I would much rather have that than that. So that's more of a CS concept than a strictly, by CS I mean computer science. That's more of a computer science concept than strictly Unreal Engine 4, but it still sort of applies. It's still sort of a thing you want to think about. When do I need these things to be organized and unique, and when do I want just a bucket of unsorted junk? And sometimes bucket of unsorted junk is the right answer, but sometimes it's not.
Right, and one of those things being the more stuff you have to keep in that bucket, the more likely you want to be able to have it sorted and stored in a way that makes sense.
All right, so everybody screenshot this because I'm gonna take this down in a minute. So just hit your print screen button, paste that into your own
Save
MS
this for your
Paint.
master class.
You didn't sign it, Richard.
Yeah, you're gonna want. Oh, you're right.
No.
You know what? I should sign it.
There you go.
There we go.
Yep, that's
There's a
exactly
dot
how
on
I
the
do
I.
it when they have the electronic
Alright.
signature at the grocery store.
And if
Just
you would like
smear
to
my
sign it with your
fingerprint
social security number or anything like that, you
I'm good.
can.
I think I don't want to take credit for your masterpiece.
Oh well, that's you helped though. You assisted. All you guys all assisted. I mean, you can. All right, so
Amanda's the artist is like,
you don't want to put your name on that.
No.
No.
Next time
Or
we'll
my
crack out
social.
Photoshop and then throw some filters on it too. It'll be good.
Oh, you want to talk about lambdas?
yeah. So a lot of times people say they'll look through the engine code and see find by predicate, and then usually some kind of fun bracket combinations. I would look up with that.
Yeah, I'm gonna do that.
Yeah. But that's a lambda, and it kind of lets you create a very small function to search an array, or sorry, a map. So you're trying to find where their keys are equal. Are you looking for?
Yep.
Let's see. Okay.
Thousands of them, or hundreds probably.
And I guess we go through breaking this down.
Let
Let's
me,
go through one that's not the source control.
Yeah. Let me open up. Okay, yeah. You want to look for a different one? I was just gonna open up Notepad because
Yeah.
we can't get that whole thing.
Let's see. Oh,
Oh, you got one?
like one of these.
Like this one?
Yeah, that's fine.
Okay. Here we go. We'll just get this.
Yeah.
Oh, there we go. That's much prettier.
Okay.
Okay, and I'm still gonna open it up here so we can just sort of.
Well, you need the whole little block there. Here.
Oh,
I'll
okay.
drop
I
it
was just
back.
doing that, but yeah,
Yeah.
go ahead.
Okay, so back over here for just a second. So user-defined pins is probably a map, and find by predicate says, okay, capture everything that's outside of this function and give it to our function to use, or to our lambda to use, and then it's going to get all the pins that are possible out of this set or map. And it will find the key and value if the pin is valid and if the pin's name equals the old name. So basically it lets you make this little tiny function. You're used to this like return nomenclature when you're in a function
Can we
block.
put that all on Notepad just because I was
Yeah.
trying to get it all in, but I didn't get it in time.
Ah, there we go. Oops.
Don't worry about the word auto right now.
Yeah.
Just you don't see that.
I will remove that in just a second. There we go. So, yeah. Basically, it's making a very small function here that's taking as inputs everything from the outside. That's what this little square brackets, you could put, say you were just trying to capture a variable named my variable, then you'd put that in there. But we're trying to grab everything just to compare to possibly. And then we found the right key if it's valid and its pin name equals this old name. So you notice I didn't have to type old name anywhere. Like it's not here as an input because we've captured it using
Yeah,
this
it's
capture
a
right
local it's a local variable or whatever.
Right. So you'll find that a lot for looking up your correct key rather than have to go get a function. If this is not going to be reused frequently, then you would use a lambda just to kind of very quickly say what's the logic for if a key is a valid key or not.
Yeah, yeah. I mean, a way to put this function in English would be like, I have this old pin name. I'm gonna like rename all the pins that used to be named old name, and I'm gonna change them to new name. So can you just find me all the things where the pin name is old name? That's what I want.
Right.
And that's what this is.
Without having to break it out into a separate function.
Yeah, and you can search your don't need this. You can search your storage class with that, and so it's just convenient. It's just right there. It's easier than you iterating through the storage class yourself.
Right.
So those are a little bit advanced, and to be honest, every time I write a Lambda function, I go look up a Lambda function in code online, and then I copy that as a template, and I modify it to be what I need, and then I test it and make sure it's right. I don't write them very often, so they're kind of advanced, so I just check every time. And so if this is a little bit intimidating with the weird symbols everywhere, don't worry about it.
Yeah, it's more like if you come across one of these, say you're looking through engine code, there's a couple questions of like, oh, I saw this in the engine, what is it doing or why is it there? It's just a really convenient way to do a lookup within your map.
Okay, so that's lambdas. The other thing that we can do is we can overload operators. So, I don't want to be in here. So, for example, I can look at array of ints. Whoops, not like that. Array of ints 3. Now, if array of ints were just a usual, were like a pointer like that, or it were an array like that, then that 3 would just be indexing into memory. It would just be saying jump forward by 3 times the size of an int, which is 12. So just jump forward by 12 bytes, treat that as an int, whatever's right there in memory. Whatever is right there in memory. So like make sure that's not bigger than the amount of ints you actually have, or you will either get a segmentation fault because you just tried to read memory that you didn't have, or on an older system, you'll just get whatever garbage is in memory there, possibly an adjacent variable, something like that. One of the older ways that people used to hack would be that they would set a variable to be slightly bigger than it's supposed to be. And you'll see if you watch like glitch runs of N64 games, like Ocarina of Time, it'll be like, well, I put this item here, so it writes the value 22 into here, and then it looks 22 spaces ahead in this array, which is invalid, and executes arbitrary code, and that warps me to here. That's what that is. That's somebody not checking that number before putting it into the array. However, the way we do it, and I don't have VAX,
Wow.
the way we do this here is, since this is not a native type, it's not like just an int or anything like that. This is a T array. So a T array has a special function defined for, actually, let me see if I can find, I really want to open T array, but I don't know where it is. Do you remember where T array is in the source?
Containers, but yeah, without
Yeah,
digging
but
through.
VAX. Let's see. Visual Studio's built-in thing did it. All right.
Yes.
Okay, so right here. So operators like this, you can overload them so that when you say equals, for example, it will do something other than what the default language is. So you can override things like an open brace. You can override equal sign, less than, greater than. And so very frequently when you go to put things into a set, it will ask you to overload the less than operator, because often what it's going to do when it goes to sort things and decide if they go, like on that cherry tree, does it go left or right? The question is this one equal to that one? If so, that's the one. Is it less than that one? Go left, otherwise go right. So it doesn't care about the greater than operator, but it wants you to define what less than is. And that doesn't make sense for ints.
Right. But it's like if you're keying off of something like our names, like what makes a name be less than another name? We could do like the length of it, or if we do alphabetical sort, things like that.
Right. Yeah, because it's clear for certain primitive basic data types like ints and floats what greater than and less than means. But like Lauren said, it's not clear for every data type how is this one less than or greater than that one? What comparisons do you make? So that's operator overloading, which you may run into. I think that really...
Yeah, we did have one question about sets and maps and keys
Okay.
from the forums that I wanted to get to while we were talking about this area.
All right, we're about to move on, so this is the best time.
Yes. And the question was that they'd seen some Tmaps that were keyed either off of pointers to actors or U objects or T-weak object pointers. So the first one is okay because even if you're going to destroy an actor, there's some very low level classes that keep information about U objects around. So that key is still something that is will have like a trace data associated with it. But if you use T-weak object pointers or T-weak pointers, you should not do that because those could be collected and then you would have two things that are sort of keyed off of something that's not being stored correctly anymore. And if you think about it, it makes sense, right? If you wanted to associate, like you're storing something really important and you want to be able to go look it up later, you want the directions to go look it up to be something that are reliable. So using a weak object pointer or weak pointer isn't good for that. I think I was talking to one of the devs in that area. Alex, you're making kind of a...
I'm sorry, I'm doing the thing where they're trying to make me laugh on here. I'm just like,
Okay. I see both
to, like-
non-engineers are looking up and to the side, which either means they're lying or thinking about something. And I suspect it's the second one since their mouths aren't moving.
no, we're lying without talking. That's how good I am.
telepathically. So I was actually talking to one of the engineers who works like sort of on the more low-level engine systems. Who says he'd like to eventually make it so you couldn't key off of that.
Yeah, make that somehow impossible.
Basically, you wouldn't be able to make a hash map of something that's a T-weak pointer, so it wouldn't give you that little like storage address anymore. So it's like, yeah, if you're gonna think of it like your address for your house, if you want to go make sure you find your house all the time, you want an actual address, not something that might change based on the day or the time or that might go away.
Yeah.
So
Yeah,
why
you-
it's not good to generally have weak keys. You want to have a good strong key that you know you'll be able to
Yeah, you
rely
want
on.
something like a non-reusable serial number, right? Like that, you know.
One that's
Some-
government issued, if you
Yeah,
can.
like that kind of thing. You would want that as opposed to something that could change over time.
Right, like you wouldn't store information about me by my hair color because that's going to be different next time you go back.
You're right. That's always going to be different. But like, what number would I use? No. Okay.
12. You can store it under 12.
All right. Well, we'll start with 1, 2, and we'll get the other 7 later. All right. So yeah. So that don't use those as keys. All right. So in case we just blew your mind with all that stuff, which is entirely possible, we're gonna take it back down to casting, and hopefully it won't get into the level of intensity of what we just did there. Okay. So the basic concept of casting is. Here's a thing, I would like you to treat it as though it is this variety of thing. So, for example, this is just whoops, I don't want to be in here. I want to be over here. All right, and just, yeah, we don't need that. So right here, for example, I have this I, which is clearly an int32, but I want you to pretend it's a float. So please treat it as a float. Now this is a little bit of a special case because those are both native types. And the processor will actually convert an int to a float. They're not in binary. They're not stored exactly the same way. Floats have a different IEEE specification standard. But for other things, like if I have an A actor, like this thing is an A actor, but I want to pretend it's a U object. All right, so that's how you do like just a regular C-style cast. Here in Unreal, you would do it this way, and you would capitalize this properly so it's a class name. So I would do that. Now that will return a UObject pointer because I said UObject right there. And it'll be null if the thing I pass in isn't a UObject or is null itself. And if the thing I pass in is a UObject or any class derived from UObject, so A actor, A pawn, A character, they all go up the line to UObject. I will get the UObject version of this.
Right.
So when you create a class that is, here, let's tab over to our H file. So this A my actor is an A actor, and A actor, since this is working, is a U object. So this is going to work because it's a descendant.
Right.
If I said this one, if I did this, Nope, that will not work. Well, it won't crash or anything. It'll come back null.
Right, so you want to make sure you check after this that this as object is not null pointer, or you could just work in here.
You can do that because that's checking it against null. If you didn't want to do that, you could do it the way Lauren just said, which would be I just do the cast and then I say if this right there. I can do that, or I can explicitly. It's not null, sir. Or I can explicitly check that it's not null. If I don't and I just use it like this and just start doing stuff with it, that will crash. Don't do that with a null pointer. So you check those first. So that's basically what casting is. And then here's a little bit more technical detail that hopefully won't be as frightening.
Oh.
Well, it will be a little frightening.
Quick
question?
question before we get too far. I don't know how quick of an answer this
Sure.
is, but why would we use just a standard cast and not a dynamic cast for this?
Well, that actually is a dynamic cast.
So okay.
So that cast is specific to UObjects.
Yeah, that's
If you
the
work in-
UE4 cast.
And it's just for comparing to UObjects. If you were writing Slate code, you would see more static casts or things like that because you're working with things that are not UObjects.
However, let's also answer why would we use a dynamic cast instead of a static cast.
Yeah.
So a static cast is when I know for certain that this thing is what I think it is. A dynamic cast has the possibility of returning null, which is good when you pass me some object. Like, all right, let's suppose you give me an actor, and I want to know if it's a U object. Well, I definitely know it's a U object. It has to be
Because it's an actor.
because it's an actor. But let's suppose you give me an actor, and I want to know if it's an A my actor, like this class I just made here.
Or a pawn or a
Pawn
character,
or a
yeah.
character. It might be, or it might not be. I don't know. So I need a dynamic cast for that because I don't actually have any way of knowing that in advance.
Right. It's kind of like the family tree thing, right? If it's somebody that you inherit from, so parent, grandparent kind of class, then you can do a static cast because you know that that's related. But if it's something that you may or may not like be a sibling of, then you should use a dynamic cast because it might not be.
Yep.
Yeah.
Of course, in UE4, I don't think I've only really used the UE4 cast.
Yeah, no, but if you're working with just gameplay code, I think that is primarily what you're going to be using because you're working mostly with actors, components, things like that.
Yeah.
Interfaces.
Yeah, even in a little bit of engine code, I haven't used it, but other people.
Yeah, but if you're in Slate, you're like, I gave you a widget, and it's like, I know it's a button, then you might have some static cast. So.
All right, so I love that I get to do this twice in one stream. It's going to be awesome.
You
All right.
get to. It's your privilege to do this. Of course.
So here's the memory layout. Like here's byte 1, here's byte 2, here's byte 3. Wow.
You're getting
There
really
we go.
good at
That
writing
looks
out
more
the
like my
numbers
writing.
there. Yeah.
So here's a U object. So a U object will have at the top, it's going to be a virtual function pointer table. Can I write this in this space? Virtual function pointer PTR. Yes, VFPTR. It looks like a D.
Yes.
We'll just fix that.
Okay.
Beautiful. All right. So virtual function pointer table followed by all
pointer.
of its data, which I was tempted to leave at D, but nope.
He's going for it.
Yeah.
There you go.
All right. So an actor, which is a child class of this, will then have a second virtual function pointer table here, and then the actor data. This one I'll just write D. So this up here, this is the U object. This part down here, this is our A actor. So in memory, that's how these things are laid out. And let's talk about why that's important. So one, the virtual function pointer table. Whenever you have a method that's overridable, like for example, begin play, right? We wrote our own begin play. And that is an override of a virtual function from A actor. So A actor also has not that one, this one. It also has this, and you'll see here it's not an override. This is the original version of it. So I want to replace the functionality of begin play with my own function for begin play. So when I do that, first off, in Unreal, this word super for UObjects references the parent class. So I do want to do everything that the actor class does, so I'm going to call that. But I also want to do my own stuff, which is written in here. So when the language sees that I've called this, and by the way, our class would be here. Right, this is the A, my actor.
It's a very large A.
Yeah! All right, so this is the A, my actor. This is the virtual function pointer table. This is the data. There we go. So when I call begin play, it knows to look here to find that. And then when I call super begin play, it knows to look here to find where that, it's finding the actual memory address where the code for the function is loaded. So that's how it knows to do that, as opposed to just running the actor version every time. So this is basically how you need to think of your class. My class is the previous class, the parent class, plus all the stuff from my class. And then the parent class could be its parent class plus all the stuff from its class plus all the stuff from my class, and so on. So where that comes into play, well, one, don't inherit from two parent classes. I'm not going to go into too much detail because it's a terrible practice, but this is okay. My child class inherits from my class. Well, that's pretty simple. This is ugly. My double child class inherits from my class and my other class. What's the problem with that? I mean, because it's two at the same time. It's not one and then the other. It's two at the same time. So a problem with this is, well, some of this has the same variable as stuff up here. That's one of several problems with this. But so basically when we inherit in this language, it's best to do it this way. If you need to have functionality that's in common with something else, but you aren't the same base type as that other thing, let's give an example. We have a character that can be triggered by an event. We have a door that can be triggered by an event. The door is an actor. The character is a character. So the character's hierarchy would look like my game character, parent is pawn, parent is actor, parent is UObject. Okay. The door actor would look like door, a actor, UObject. So you can see that at a actor they have a common parent, but the lineage is pretty different after that. The door should not be derived from my game character because there's going to be a ton of stuff in my game character that the door doesn't need to have.
Yeah, unless you're doing some very strange game where the doors just pick up and walk off if you don't unlock them in time.
Yeah, kind of like a Looney Tunes kind of thing, where it was just sprout feet. Yeah, but unless your doors are also characters, don't do this. But let's say they both need to respond to game triggers. I walk into a thing and it says, okay, trigger all the things that are on this list to do whatever they do.
Right.
So in that case, that's where we'd use an interface. And an interface is basically be like this. It would start with an I. And an interface has only functions in it. It doesn't have data members in it. So you use the U interface for that. And normally we would have a whole session where we show you how to create U interfaces. But Lauren and I did that a while ago and decided it was a little bit of a pain. So we'll put this here. So just use that. And then basically you just implement it the same way as you saw right there with my double inheritance. Just like this, except that this should be an interface. And you can put any number of interfaces, it's fine. The only caveat is, for linguistic clarity, don't make really common function names as part of your interface. Because then, you want it to be clear when I say game trigger that I'm definitely talking about the game trigger interface and that the door doesn't also have a function on it that's coincidentally named game trigger for no reason.
Yeah.
Just don't double use names. But that's about it. That's about the only rule to be careful of there. So this is how you would allocate memory in a C environment. Don't do this here. We use new object. And this is how you would deallocate memory in a C, C++ environment. But again, not necessary here. Like for actors, for example, we'd use destroy.
Right.
You don't actually manage memory yourself. I'm only doing this here for demonstration purposes. And the purpose is to show how constructors work. Because we do override constructors in here, like right here. I wanted debug mode to be true by default whenever we create a new one of these things, so I just set it right here in the destructor, or constructor, sorry. So what I've done is I've written these classes, and they output, where were I? We're here. Oh, we're in the H file for this. It's this one. So I've written these classes, and all of them, they just output the name of the function, which would be this, whenever they run. Hey, by the way, this function with the double underscores, that's one you can use. Line is another one. They're built in, but it can be pretty nice if you want to like output some sort of unique error message, like crashed at function whatever, line whatever. Every time you compile, the compiler will look at that and will change it as you go through, so it'll be exact to when this program was made. So as long as you have the source code, you can get the exact function name or line number or whatever you want in your debug output, which can be really helpful for tracking stuff down. The call stack will often tell you that information, but here you can get it in your log if you don't have a full-on crash.
Right.
And you just see something weird, just output log temp warning, saw something weird in the check at line blah in function whatever.
Yep, and then add a little note, like go fix that,
Yep.
maybe.
And this isn't Unreal specific, by the way. You can use this in any C++ program. I think pretty much every compiler in the world supports this. So, so that's just a little extra thing there. All right, so when we run this, at the bottom of the program, after we do all this array stuff, you may have noticed this output before. We create one of these, and that means it's going to run its constructor. And then at the end, we delete it. You notice that I null check it before trying to delete it. And that means that we're going to run its destructor. So right now, before we even stop the program, you can see that we created it here, and we have 3 lines. And then when we stop the program, whoops, in here, there we go. We have the 3 destructors. Let me just see, what did we do here? Good. Okay. So back to here. So what you'll notice is that the order of build up and breakdown are opposite. When you have a constructor, it will call the constructor of the parent class before the constructor of the child class. And for double inheritance, it's just whatever order you listed them in, it'll go in that order. I'm not even sure if that's deterministic between compilers. It probably is. But don't use double inheritance, so don't find out. And then when you break them down, it's the exact reverse order. So it's like 1, 2, 3, 3, 2, 1, right? Parent, child, grandchild, grandchild, parent, grandchild, child, parent. There we go. So there's a good logical reason for that. Do you have any thought on that?
I mean, it's good to also make sure that, like, no, I think
Okay.
I was like going to say if there's anything to add, but.
Okay, well, the reason that I think this is especially useful is because if you are a child class, you know what your parent class was. So the parent class is already and assembled in its default form before your constructor starts. If you're a parent class, you don't necessarily, if you're the code in the parent constructor, you don't know that this is actually being run from a child class. Like, you have no way of knowing that. So it shouldn't matter to you if the child's stuff is initialized or not because you're unaware of it. The child class, on the other hand, is aware of the parent's stuff and might care what some of those initial values are. Right. So that's why that runs in that order. And the same thing for a destructor. The child class might have to look at something in the parent class to determine how it's going to do its destruction. But the parent class will never have to refer to something in the child class because for all it knows, it's not even that class. That class doesn't have to exist as far as it knows.
Oh, I do know what I was going to say. In the begin play where you overrode,
Yes.
so this order is for constructors and destructors, but if you override a function,
Yes.
you can actually change the order that you're.
Oh, wow. Speaking of which.
Oh, yeah.
Whoops, nobody saw that.
Well, they didn't until you called it out.
Well, that's okay. I was just seeing who was on their toes. Yeah, chat. Did you notice that I didn't call super for no reason?
It's kind of important to make sure that the parent gets called.
Yeah.
So, actually, there are some cases where if you know both the child and the parent and you're sure you don't want to call the parent behavior, you can actually completely override it. But for things like actors, you always want the parent behavior because there's a lot of very important things in there. But you could change the order and put this end play before the child behavior, so you could put the parent behavior first, or you can switch it and do the child behavior first. So the constructor and destructor are the main places where that's like completely deterministic behavior
Yes.
and not up to you to be able to switch around.
Yes. Anywhere else, not only do you have to remember to call it, but any good programmer would. But you also have to choose exactly where it's going to be called. And in some cases, as Lauren said, I was doing some game code a little while ago, and I had a general way that people in the game would move. But then there were certain characters, like the little bats that fly through walls and that kind of thing, that they don't adhere to any of the normal rules. So I just overrode the tick move function for them and didn't call the parent class. The parent class doesn't. I don't want the character to move twice. I don't want any of that. I just want this one specific type of character to have special movement code. And it was better than duplicating the regular movement code for someone else, and I didn't feel like breaking it out into a separate thing. So that's an easy way to do that. And there are rare cases, but they do exist where you're not programming wrong. You just really don't want to call the parent version.
Right.
But not in this case. In this case, like for whenever an engine object is being destroyed, you should call that because you don't know what other loose ends might not get tied up if you don't call that. Speaking of code duplication, I marked some code duplication here. So as I was writing this, I wrote this one output line, and then I was like, also, since that first output line happens before, I wanted one that happened at time 0 when we have nothing added, just to give us a baseline, and then I wanted to have one after everything was added. So, I mean, I could have done this, right? And this wasn't originally in there. I could have done this. That's fine. We'll leave it. But then this is just the same as that. So then this would just end up being up here, and we still have code duplication. I could also have put in like a special check to see if this is our first time running through and print it out beforehand only. But then that means I have an if that gets checked every single time, and only one time does it ever actually fire, which just, that's yucky. Don't do that.
Yucky, of course.
Yeah, running branch statements that are going to fail most of the time when you really know that you only need to run it once, don't do that. It's sloppy. But code duplication, see, as I started to expand it to 3 things, I started to change what information I was outputting, it got to be really messy because, every time I make a change up here, I have to make a change down there. For one little debug output line, I don't care, but once you start doing 3 lines and you're changing things, no good. So we want to make this another function. This is just general cleanliness in programming. We'll make it a protected function. We don't need this to be called from outside. Void debug print stuff. We don't even need any arguments because everything's a class variable. And normally I wouldn't put it here just for organizational purposes, but we're being quick, so I will. Thank you. All right. Wait, yes, it was before, yes. And then we avoid code duplication by just doing that.
I think Alex has something he wants to.
That was it. It'd be like you just a small syntax thing.
I saw the pointing.
Just like please don't miss that. I don't want to have to go through the compile error for tiny syntax.
So
thing.
I mean, we'll just talk right past this because that's theoretically going to do nothing any different from. There you go. Yep, same thing. It does nothing any different from it did before, which was the point.
Yes.
Okay, so I think we covered that. We covered that amazing memory map that I drew.
Yeah. Actually, I want to point this out. By the way, while we were doing this, someone made a 3D paint.
Oh,
version.
thank you.
Thank you.
That
Thank
is
you.
very
That looks
exciting.
really
Thank you,
nice.
Jan.
Can we?
Very
Is
cool.
there any way we can get that like
Are we zooming into my laptop?
No, it's been sent over there. Okay.
Oh, you actually have it? Perfect. We'll display that in a second. But I have to say, that is an impressive turnaround time between we did it live and you guys are already making fun of us.
Thank you. Oh, but hey, yeah. Now remember, that's O log n. I don't know why it says n log, but still, this is. Wait, hold
He's
on.
doing
Is
it
that
from
what we're showing on
memory.
the stream?
There
we
you
go. There we go.
Now that it's 3D, it's extra helpful.
So that's
Yes.
log n search time
That's pretty awesome.
on a radioactive cherry tree. Okay, so we answered that already. How do we know what header file from the engine? Oh, yeah. So we're doing questions.
Yeah, okay. So onto the Q&A. First, we'll go through the stuff from the forums. Then we have a couple at the end from chat that were asking us questions live.
Okay.
So yeah.
Are those just going to get in here, or?
Yeah. There's actually a few that I've already tagged on to the
Oh,
end.
great.
But you go up to the top first and work your way down.
I think we didn't
And
get question number
We'll
1.
try not to
We
go
got-
too far over
skipped
time
ahead to
because we're already a
2.
little bit over time.
I think we're skipping that one. Yeah, I forgot to mark that one. So, how do we know which header file from the engine to _include in your own C++ class? Okay, so you have a C++ class.
So he added a hashtag. It's not
hashtag,
pronounced pound.
Yeah.
Not anymore. It could say Octothorpe. That's also accurate.
Octothorpe.
That's the original name.
I learned something today on the training stream, so
Today I learned.
Hashtag Octothorpe.
So,
Look at that happen.
all right. So, how do we know what to include? Well, all right. So there are a couple of things. First, here I'm using these classes that I defined elsewhere. So since I only refer to them by pointer in the H file, I can avoid having to include them at all. I just forward declare them so the engine knows this is a class. As long as I just refer to them as a pointer, I don't refer to anything inside of them. I don't have to know how much size, how much space they take up, anything like that. It's just a pointer. Like down here, it's just a pointer to it. I never look at its internals or its size. I can do this and it's fine. Now over in my my CPP file where I actually
you make one, right? Yeah.
create one of them, now the program has to know exactly what I'm talking about, not just, I promise it's really a class somewhere, I just want a pointer to it. All pointers are the same size, that's why it doesn't care, it's just a memory address. But as soon as we want to do anything with it, then we need to include it. So in this case, I've only included it in my CPP file. That way, anything else that includes my H file doesn't also unnecessarily include this, which will increase my compile times significantly. I think we went over that last time, but this question goes a little bit further and says, you know what, I'm not going to Google search right on here. I'm just going to go over here and then Google search. So let's suppose that we refer to a uSphere component. And this time I'll actually type in UE4. OK. So I type in uSphere component UE4 to Google, and then I go here. OK. So there it is. That's the header file you want, and that's the module that you need in your build.cs.
Mm-hmm.
That is probably the easiest and best way to figure that out for basically anything in the engine. Just right there at the bottom of our API documentation.
Mm-hmm.
So that's that.
I have an updated version of the nlog.
Oh, you do? Well, definitely put that up. If someone put the effort to update that thing, then I definitely want to put that up, and we'll
Thank you,
read
thank
the
you.
next question
Now
while
it's
we're
got
doing that.
UE4.
Oh, that's beautiful.
It's amazing.
That's
Okay.
great.
That's awesome.
That is great. Thank you very much.
I think we cut the second n off of nlog n though, right? It's supposed to have a.
Well, it's supposed to be big O log n.
Oh, okay, that's the
I'm
different
just
one.
I'm just trying not to nerd out too much about it. All right.
That happened.
Oh, this one's you.
The AI question I think we're going to put in the forums.
Yeah, there was an AI question about using navlink to kind of like jump between platforms, and the guy would just kind of run up to it and not jump between platforms. But yeah, I'll hop on the forums and do that,
Okay.
since that's more of an AI question than one that is specifically about the C++.
That's true. That's a little bit out of scope, but that'll be on the forums.
Yeah.
Okay. Let me see. All right. So this one I'm going to touch on just briefly. do we have a way of destroying actors without causing other actors to crash when accessing data from the destroyed actor? Yes, there are a few things you can do to protect yourself from this. One, null check things. Two, have all your actor pointers be U properties. It doesn't matter if it can just be just a plain U property like this. It doesn't need anything in it.
Right, so this means that the engine is going to keep track of the actor for you. If you don't have that, then garbage collection can come clean that up like, oh, nobody's using this right now, and you might be surprised when you try to use data from the actor later.
Right, you will be left with a pointer that still has the location in memory. It would be just like Boys of Summer, right? You're driving by the house, but that person's not home.
Now that song is going to be stuck in my head.
It's a good song, though. It's not the worst song to have stuck in your head. But it is like that. You have the address of the thing, and you can go there, but that actor's not there. And what might be there is a whole big pile of hot garbage that you do not want to access and treat like it's an actor pointer, because you will almost certainly crash. And if you don't, it's actually worse. Because that means
some nonsense data that...
Yeah, that means you have some horrible bug in there that's going to be way harder to find. When you make a mistake like that, the crash is definitely your friend, because you know something's wrong.
Yeah. Then there's also, T-weak pointers.
T-weak, it's just object, yeah, there it is.
Yeah.
Object pointer.
Object pointer. There we go.
Right, so that's it, right? You don't need the asterisk in there, yeah, so.
Of course, it's yelling now, so I'm there.
I don't think it,
Okay.
yeah, it hadn't parsed that yet. That, I think, does not need to be a U property.
Right.
Because it's a T thing anyway. It's one of Unreal's own classes. So Unreal will figure it out. Unreal will know about it. Same thing if you made a T array with a bunch of actors, actor pointers in it, right?
And why store actor pointers and not actors in the array?
Don't store whole actors in there, because you don't want to duplicate them. You want to store a list of the addresses of actors,
Yes.
right?
You don't want to put the whole house there.
Right.
That's a
An
very
address
big
book
array.
is reasonable to have. A meat locker full of people you know is not reasonable to have.
This is a good metaphor.
People will remember that one, I think.
Right. I think that will be memorable. I do.
Yeah.
Hey, speaking of memory management, the last question on here, which I feel like ties into this pretty well, is why do you recommend against manual memory management? Is it because stuffing the people into the meat locker is so difficult? Do they fight you a lot when you do
So,
it?
manually managing memory, that's good. Manually managing memory is good if you're if you're writing like your own separate library that you're going to include that's totally outside the engine or something like that. Like that's fine if you're writing a general purpose library. Well, you have to, but in here, it's not as good an idea to do. We have a whole garbage collection system. It's really robust. It takes care of everything that needs to be done. Not using it means that you and it are both allocating memory, sort of
Almost competing.
You're kind of stepping on each other's toes. And the people that we have working full time on this, who are really really good at it, have written a system that you're now duplicating for some reason.
And the garbage collection system is pretty easy to tweak, even inside just project settings. You can be like, oh, collect more frequently, or only collect when it gets to be this unwieldy. So,
yeah, the effectiveness of spending time on learning how to use our garbage collection system a little bit better, like in terms of a value per unit of engineer time that you spend, is way, way higher than writing your own. I would really not advise you do that, unless, again, you're writing a little external library that you're going to pull in which case you basically have to if you want a general purpose library that isn't only a UE4 plugin or something like that. But yeah, don't manage your own memory. In general, in almost any game engine, you don't manage your own memory. You almost always let the engine do that. Yeah, that's generally the safe way to go with that. So anyway, those are some ways you can avoid that. And again, if you sorry, go ahead.
oh, like so, it's the storage. Have you stored as a U property or a pointer or a T array?
Yep.
But also, when you access it, making sure that it's not a null pointer or that the two-week object pointer is valid. And you do want to do that every time you dereference it. Every time you've got the little arrow accessing data from it because it could have been collected by the garbage collector somewhere in between then, and so you wouldn't want to do it even at the start of a function block. You want to always be like,
Yeah, you just always null check. Just basically before you use anything, just look at like, have you given me something good or is this just a null pointer? Okay, it's something good. All right, now let's do stuff with it. That's fine. So
Now, in the other occasion, of course, since this is basically just an if branch where you're doing this is valid check for the null pointer, right? If it's not there, it just comes back as false and just does nothing and skips it instead of crashing. Or are we still going to get that horrible crash?
oh no,
and-
you'll skip if it's like, you know, if you
Yep.
if it's not.
This is what Seto-kun is asking: is what happens if it's not valid? Your is valid pointer does go to a null pointer or to something else.
all right, so it would be the same
And-
thing as this right here.
Yep.
If this isn't null, again, don't do any of this. But
Yeah.
but basically, this is the format. If this thing,
If
or you,
true.
or you can explicitly say this
Yeah.
thing is not null,
Mhm.
right? Then go ahead and operate on it. Otherwise, just don't operate on
Yep.
it.
Just skip going to the next
And
thing. So that's.
When I wrote
I
that
hope that
cast
answers your
line
question,
earlier,
Seto-kun.
right? When I wrote that,
Mhm.
that was the point of putting that in an if, because it was here. Or as Lauren said, I could have written just the cast line and then if this as actor is not null,
Right.
then
'cause
do
you
stuff
might
inside the if.
want to, you know, reuse it, things like that. So
Yeah.
Yeah.
Yeah, so this is this is just checking the reference when I do this kind of if statement versus creating the reference for usage later is what you're saying. Okay,
Yes.
that's cool.
Are there plans to add creation of U structs through the editor similar to U classes? No, there really aren't. But U structs are pretty. U structs are pretty easy
This
to
will
do.
probably have to be the last question.
Oh, okay.
Yeah, sorry.
U structs are actually pretty easy to construct. You just.
I was trying to be subtle.
You can just throw your shoe or something. It's all right.
she comes flying from off camera.
We get the outro music for the the Oscars.
And
so
that's
it's
it.
cranking up over time.
Let me just get that.
You can pay for that, right, Clint?
Totally.
You can license that.
I can put music over it.
Yes.
Okay. So that's pretty much all that we need to do there.
Yeah. So we do have things like that, like the template for interfaces, but that's because there's a lot more boilerplate that goes into it compared to this, which is pretty
Yeah.
straightforward.
So there we go. And we're out on that one?
Yep. So that'll be it for that. Thank you both so much for coming out here and discussing all this with us, answering all the Q&A and helping follow up with stuff. We'll also be checking out forum.unrealengine.com on the events section about the C++ Q&A section, where we will be following up with any questions that we couldn't get to here, and I'll follow up with the AI question that was a little unrelated as well. So this upcoming Thursday, that is to say in 2 days, we're going to be having the UE4 Jam, Summer UE4 Jam kickoff, where we're going to get to announce the theme.
Yeah.
That'll be a lot of fun. That'll be us two and Chance is also, Chance is actually going to be coming back on for a stream, which is difficult to get him out here these days. Yeah, so come on Thursday, 2 p.m. We'll see you all there. And also thank you both again for coming out. And so yeah, we'll see you
All right.
later.
Bye, guys.
Bye-bye.
Bye.